Monitoring soil moisture is one of the easiest ways to improve plant health and conserve water. Let's take a look at how to use PASCO's wireless soil moisture sensor both indoors and outdoors. The wireless soil moisture sensor measures the water content of soil and reports it in units of volumetric water content percentage, or percent VWC. VWC is the ratio of water volume per unit of soil volume. The sensor comes with a USB charging cable, and you will find the probe inside a bag. To attach the probe to the sensor box, just line up the arrows and gently push. The sensor works with either SparkView or Capstone software. I've already connected this sensor in SparkView. You will see that there are 3 choices for percent VWC because different types of soil have different properties, resulting in different VWC ranges. I'll be working with potting soil, so I will choose the low measurement. You can choose to display all 3 soil types if desired. The sensor can be used indoors or outdoors. If you're using the sensor indoors with the potted plant, make sure that the pot has enough soil depth to accommodate the sensor blade. If you have a small potted plant like this, you can insert the blade vertically. You can see that there is 12% water content by volume. When you remove the blade, do not pull the probe by the cord. Instead, grip the probe like this. You can use the same method for outdoor measurements as long as the probe can be inserted into the soil without excess force. However, the probe is most accurate when placed horizontally with the blade perpendicular to the soil surface. This ensures maximum contact between the soil and the probe at a given soil depth. To use the probe outdoors, dig a trench about 10 inches long at the desired depth with the minimum depth of about 1 1/8 inch. Separate and keep track of soil as you remove it, so when you get to the desired depth, you can place the soil that came from the deepest portion of the trench alongside the probe. Place the probe in the trench horizontally and orient the probe blade perpendicular to the soil surface. Cover the entire probe with soil and tamp the soil with your fingers to match the natural compaction of the surrounding soil. Replace the soil in the order it was removed. Compact to the natural compaction, and take the soil measurement. When you're done taking the soil measurement, avoid pulling the probe by the cord. You want to carefully unearth the probe to remove it. Like this. Consider having your students compare a field study of soil moisture either on campus or off-site on a field trip. If students use a GPS-enabled device, such as a smartphone, they can record the VWC percent at specific latitudes and longitudes, then use Esri's My Maps tool on arcgis.com to create different visualizations of soil moisture at specific locations within the field. Here are a few data points for surface soil type versus VWC values at 3 different locations around PASCO headquarters. This blue circle represents silty clay soil, and these 2 red circles represent sandy soil. The size of each circle relates to the magnitude of the VWC measurement relative to the entire data set. You can see how these kinds of visualizations help students identify soil moisture patterns. Visit the experiment library at pasco.com and look for the investigation called Soil Moisture Field Study to find an outdoor soil moisture investigation like this that uses an online Esri map in addition to other investigations. Thanks for watching, and see you next time.